Okay, so today we're going to look at complex numbers, and we're going to simplify them into the form of a plus bi. So when you have a problem like the one you see here, 8 minus 3i all over 7i, what we want to do here is clear the denominator, okay? We want to rationalize that. So how do we do that? Well, we're going to just multiply both the top and bottom by 7i. Okay, now if I do that, my top will look like 7i times 8 minus 3i, okay? And the bottom, of course, is 7i times 7i, okay? So on the top, you want to go ahead and distribute. So you have 8 times 7. Okay, so 56i minus 21i squared, okay, all over 49i squared. And then we continue to simplify this. So here, your I squared we know equals a -1, right? I times I is a -1. So this becomes 56i, okay, and then minus a minus 21, if we want to keep our signs correct, all over 49, and that will be a -49 because, again, of the I squared. Okay, and now we're going to go ahead and simplify. So I have 56i plus 21 all over a -49. And then what we can do here, in this case, I guess, is we can actually go ahead and pull out a greatest common factor, right? So what do we see that's common in all of this? Well, we see here that a 7 will go into all of these things, right? So I'm going to pull out a 7 on the top, and that's going to give me an 8i plus 3 all over a negative. And if you think about pulling this out, it's 7 times a -7. Or you could do it the other way too. It really doesn't matter. Okay. Now the 7's here cancel out, right? So your answer then we're going to pull that negative out front. Okay, so you have an 8i, or an 8/7 I, if you want. We could just do it like this and say an 8i all over 7 plus 3 over 7. So there are lots of different ways that you'll see this problem written, right? So there's lots of combinations. In your book, the answer actually looks like this. They say a -3/7 minus an 8/7 I. Usually that I term is on the end here. So however you would like to write it is fine. I think the important thing is to have some confidence in how you write it. Someone else had asked about pulling out that greatest common factor. You don't really need to do that, but you're welcome to. So lots of variations to a correct answer here, but if you're able to look at your answer and see that it could become this, that's the most important thing. Okay, so let's try one more. Try this problem. So this is very similar. We're going to multiply both the top and the bottom by 8i. Okay, and so on the top, that looks like 8i times 2 minus 4i. And then on the bottom, of course, it's 8i times 8i. So on the top, you have a 16i, and then minus a 32i squared, And all of this is over a 64 I squared. Okay, so we'll continue to simplify here, 16I. And then here, we know what happens with that I squared. So we know that that's going to become a positive 32 because this I squared here equals a negative 1. Okay, on the bottom we know that I squared equals a negative 1, so the bottom becomes a negative 64. So kind of like the previous problem here, you can pull out a 16. Okay, and if you want, we'll even pull out a negative 16. It doesn't really matter. Okay, but what that leaves you with then is an I plus 2. On the bottom, it's a 3. So now you can see that if you pull out that negative here, oops, I'm sorry, this should be a 4. Not 48, 64. Okay, so here, 4, there. All right, so what you can do now is see that your 16 over a negative 16, that's going to equal your negative 1. Okay, and then you have an I plus 2 all over 4. And again, variations with this problem, right? So you could write it like this. You could say a negative 1/4 I minus 1/2 because 2 over 4 simplifies down into a half. Okay. Most commonly, it would probably have the I term at the end. So you could say a minus 1/2 minus 1/4 I. You know, you can pull out that negative like we just had it. So lots of variations again, but the same basic principle as the previous problem. So I hope this helps, and certainly let me know if you have additional questions.